Welcome. This is Algebra 1. My name is Mr. Hinton, and we're in pod number 1, which is section 10.2 from our Holt Algebra 1 book. We're going to be dealing with stem and leaf plots, frequency tables, and histograms. Let's begin. Stem and leaf plots, frequency tables, and histograms. Our objective is to organize and display data using these things. Okay, stem and leaf plots. A stem and leaf plot arranges data by dividing each data value into two parts. So if the number 23 is in our data, we would divide 23 into 2 and a 3, and we'd show it like this: a 2, a vertical bar, and a 3. The value 87, we would divide the 8 and the 7 and put a bar between them, a vertical bar between them. What if we have a 3-digit number? The data value 351 would be divided into a 35 and a 1. So the second one is always going to be a single digit. And similarly, the value 812 would be divided into an 81 and a 2. The first numbers in these are called the stems, and the second numbers are called the leaves. So in this, it's written as stem and leaf. The 2 is the stem, the 3 is the leaf. Here in 35/1, the 35 is the stem, and the 1 is the leaf. Okay, example 1. We want to use the following data to make a stem and leaf plot. So here's our data. We're going to make a stem and leaf plot from this. We find the smallest number. Well, 21 is the smallest number of all those, and the largest number is 47. Look at the first digits, a 2 and a 4. So the stems on these would be 2 and 4, and in fact, we need to include every number between them. So our stem and leaf plot at the right, we will enter a 2, 3, and a 4 for the stems. 2, 3, and 4 for the stems. Okay, now we're going to go to the data and go through the data, and we're going to enter in the leaves that go along with these. So for instance, we look at this number 35. So here's the 3. We would have to put the 5 over here. A 21, we'd have a 2, and we're going to put a 1 over here. And you'll see how all this data comes up in here. So notice 2, 1. That's this 21. There's another 1 after it. Well, notice that there's two 21s here. A 28 and a 29. There's the 20 part. There's the 9. Notice we have a 33, a 35, and a 39. Here's the 30. There's 30 with a 3. There's 30 with a 5. There's 39. And similarly, this would be a 40, 44, 47 that correspond to 40, 44, 47 from our data. These are stem and leaf plots. We're going to do another one now. In fact, we can show two sets of data in a single stem and leaf plot by making it be a back-to-back stem and leaf plot. Back-to-back stem and leaf plot. So we're going to have two sets of data we're going to show in here. Example 2. Bob and Ron went bowling, and they got the following scores. So here's Bob's scores. Notice that they're all 3-digit numbers. And here's Ron's scores. They're all 3-digit numbers. Okay, we need to find the smallest one and the largest one again. We're going to create a back-to-back stem and leaf plot. The smallest number is 134. The largest number is 168. So our stems, now notice we look at the first 2 digits here, the first 2 digits here. I see a 1, 3, or a 13, and a 16. So our stems are going to be 13, 14, 15, and 16. The smallest starts with a 13, the largest is 16, so I need the 2 between them also. Now, in a back-to-back stem and leaf plot, the stems will be in the middle of the plot. So they're going to be right in here. There's our stems. Notice we got our stems again from the smallest number is a 134. We take the first 2 digits. The largest number is a 168. We take the first 2 digits. There's the 13 and the 16 that are those first 2 digits from those 2 numbers. And we have to include the others in there. Now we're going to fill in the rest of the data. So for this, now notice that Bob's data is going to be on this left-hand side. Ron's data is going to be on the right-hand side. So for 137, where it says 13 here, that's actually 130. We're going to put a 7 over here. 144, 140, we're going to put a 4 over here. So here's Bob's data. We have a 134, a 137. 134, 137. The 144 is right here. A 150 from the data, and a 168. Now we're going to look at Ron's data. We're going to plug these numbers in. So notice we'll have a 149 and a 148. So here we have the 140. We're going to put a 9 and an 8 in here. Usually put them in the right order, 8 and 9. We have a 153 and a 157, 153, 157. And then finally the 160. Okay, so both sets of data are shown, and it's very easy then to compare and contrast the two sets of data. Okay, frequency tables. The frequency is a value is the number of times that it shows up. How many times a particular number shows up. So when we're making a frequency table, we're showing the frequency of each data value. In other words, how many times does each data value show up? And sometimes instead of individual values, the data is divided into intervals. That will be our second example there. And the frequency of each interval is shown. Okay, example 1. The following data is displayed in the frequency table below it. Okay, I start looking at the data. These are all single-digit numbers. The smallest one is a 1. The largest one is a 6. Those values are going to go here along the left-hand side where I say scores. So 1, 2, 3, 4, 5, 6. And then how many times do they show up? So let's look at a 1. There's a 1 that shows up there and a 1 that shows up there. It shows up 2 times. So we would put a 2 right here. I will here in just a second. 2's. There's 1, 2, 2, 3, 4. So we'll put a 4 here for the 2's. Notice there are 4 2's. How many 3's are there? 1, 2. So we put a 2 here. 4's. Well, there aren't any 4's, so we put a 0. And notice there are 4 5's and there is 1 6. That's where those numbers come from. This is a frequency table. Next example. The scores for the algebra test are listed below. They want us to make a frequency table with this data, and they want us to use intervals. So instead of single numbers, we're going to use intervals of numbers. Now, what does that mean? Well, let's see. Here's my intervals, and just because it's easy, I'm going to go, well, the interval from 60 to 69 is going to be one set, and I'm going to count how many numbers there are that are between 60 and 69 inclusive, and I'll put little marks over here, and 70 to 79. So I have 4 different intervals that I'm trying to do. So let's go through. From 60 to 69, how many are there? There's 1. There's 2. There's 3. And that's it. So there should be 3 here. So notice that I put tally marks. 1, 2, 3 tally marks. From 70 to 79. So any number in the 70s. There's 1, 2, 3, 4, 5, and 6. And notice that there are 6 tally marks written down here. And likewise, there are 6 numbers that are in the 80s, and there are 5 numbers that are in the 90s. If you count up here, you'll see them. And so we start off by just putting the tally marks in, and then we usually put the actual numbers in there for frequency tables. Now we're going to go to histograms. A histogram is a bar graph. So it's a fancy name for a bar graph. And it shows the frequency of data divided into equal intervals. Now, the bars in a histogram must be of equal width and should touch. They should be touching. In a bar graph, they're usually spaced out a little bit. And what we're going to do is take the data from the previous frequency table to make a histogram. So here's the data from the previous frequency table that we have. And we're going to make a histogram out of this. So along the bottom of the histogram is going to be the scores. That's going to be our horizontal axis, and the vertical axis is going to be frequency. So here's scores down here. So we would just start off by putting our scores, 60 to 69. That's one interval. 70 to 79, 80 to 89, 90 to 99. And then frequency as we go up, notice it goes from 0 up to 7. My largest number was a 6. It goes up to a 7. So from 60 to 69, I had 3. So the bar goes up to a 3. From 70 to 79, I had 6. So the bar goes up to a 6. Notice that the bars are touching. 80 to 89 is a 6. So it's the same height here. And 90 to 99 goes up to a 5. There's 5. Notice again, the bars are all touching. They're the same width. This is a histogram. So it's a fancy bar graph dealing with numbers. Okay, one more topic here, cumulative frequency. Let's go back to the frequency tables, and we want to add one more column that's called cumulative frequency. And what does that mean? Cumulative frequency is simply adding up the frequencies as you go along. Well, let's take the frequency table that we had before. This is a frequency table from previously. And all we're going to do is have a third column out here for cumulative frequency. And we're going to add up as we go. So we've put cumulative frequency out here. So we're not looking at these numbers under score. We're looking at the frequency. And so when we start, how many have we got so far? 2. So in cumulative frequency, I put a 2. Then the next frequency is a 4. How many is that total? 6. 2 plus 4 is 6. Then 6 plus 2 is 8. 8 plus 0 is 8. 8 plus 4 is 12. 12 plus 1 is 13. Cumulative frequency takes all these frequencies in order, starts, and it adds them up as you go. Cumulative frequency. That's it for now. Have a great day.